R-CADT is pleased to invite you to participate in the course. Mastery in Applied Mathematical Programming. From real-world practice to academia. R-CADT, Research Center for Advanced Decision Technologies, is a division of Hypothalamus Artificial Intelligence Incorporated, USA, oriented to research, technological development and innovation, RAND+I, in high-complexity mathematical modeling, with an emphasis on optimization, whose mission is to bring its benefits to humanity, which involves enable professionals to successfully apply optimization technologies in their organizations, and to be entrepreneurs and mentors of new companies, spin-offs, that bring the benefits of optimization technology to society. Currently, the central topic of R-CADT's research is augmented artificial intelligence and more specifically artificial hypothalamus. To fulfill its mission, R-CADT has created a set of courses in advanced mathematical modeling that are aimed at supporting professionals interested in receiving applied training, at the state-of-the-art level, based on the experience capitalized on over 50 years executing engineering projects and development of analytical software. Mathematical programming, also known as optimization, involves using mathematical models to find the best solution to decision problems by optimizing a function, such as profits or costs, subject to various constraints. This powerful technique is applied to complex systems for planning and allocating resources in fields such as economics, engineering, and business. Mathematical programming is used in various sectors to make better decisions and improve efficiency, for example, manufacturing, optimizing production schedules to fulfill orders, logistics, plan the most efficient routes for shipping and delivery services, finance, select an optimal mix of assets to maximize returns and minimize risk, energy, determine the most cost-effective way to distribute electrical power, and sports, creation of optimal game schedules for professional leagues. The expression mathematics is gold can be interpreted, referring to the golden ratio for its use in art and design to achieve harmony and beauty, or to express the great value, usefulness and wealth of knowledge that mathematics brings to life, science and technology. In short, mathematics is a treasure trove of knowledge. In today's technology-centric era, the richness of mathematical programming is focused on the immeasurable practical and knowledge value it offers in all aspects of life. Mathematics is the language of nature and the basis for understanding the order and structure of reality. Mathematical programming has not stood out for its massive application, and it is easy to see that the vast majority of those who study and learn it do not use it to solve problems in the real world, which becomes a great cost for humanity. However, the new era of accelerated artificial intelligence will force managers and executives of companies to use it to be competitive based on, at least, profitability. In practice, you can no longer compete without mathematical programming. Aimed at professionals, engineers, mathematicians, physicists, consultants, economists, data scientists, software developers, etc., who require and or wish to know mathematical modeling, advanced analytics algorithms, related, among others, to the implications of Industry 4.0 and its relationship with the process of evaluating the technical economic impact of the decisions that are made. This continuing education program strengthens the analytical skills and professional criteria of the participants, so that they can exercise, share and or supervise, with propriety, the professional functions in accordance with the state-of-the-art of the methodologies and technologies that support the digital transformation of the companies. Mathematical methodologies. Mathematical methodologies correspond to the scientific foundations for implementing mathematical optimization models. Specific objectives: training in fundamental methodologies to support modern mathematical modeling. To train so that the mathematical modeling of industrial and business processes is a generator of real socioeconomic wealth frequently used in our society. Understand that optimizing the use of resources is the scientific basis of sustainable development. Learn about systems and industrial market modeling. Learn the fundamentals of modeling real problems based on the integration between mathematical models and data models. Information technologies. Computer technologies correspond to the computer tools available, freely or commercially, to design and implement solutions to problems in social or industrial organizations. Specific objectives: Learn how to implement solutions applied in the real world by making use of the modern computer technologies available for the algebraic modeling of industrial and business systems. Present and manage live tools used by large companies to solve their optimization problems. Understand the state-of-the-art of optimization and its relationship to smart computing. Know the available technologies, as the principle of basic knowledge to be able to solve, in reasonable times, problems with millions of variables. Know the fundamentals that must be had for the assembly of models using the most effective technologies. Disruptive modeling methodologies. They are associated with the new vision of mathematical modeling based on hypothalamuses and artificial brains, created by high. Most of the things and processes that humans use have been totally affected by technology, which has opened up to the human imagination producing previously unsuspected results. Mathematical modeling should not escape this process, starting from discovering the mathematical foundations that serve to establish the laws that govern physical, industrial, economic, biological, health, and social laws, and with them build mathematical models, and increasingly powerful calculation algorithms. Nowadays all knowledge and technology are available to develop a higher-level artificial intelligence, which emulates human intelligence in any type of human organization, and can be called the artificial hypothalamus of the organization. The power of today's technology is not in the mathematical calculations it allows to be performed, it is in the mathematical calculations we can imagine we can perform. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: neocortex, hypothalamus, and hippocampus. The traditional decision support system is conceptualized as a set of mathematical models, which exchange information between them, working offline. The artificial brain is the evolution of DSS under Industry 4.0. It is conceptualized as a set of mathematical models that exchange information autonomously with each other, working online using distributed optimization. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. This is how the human brain faces reality, using multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by Optex, the cognitive robot of High, using the models that traditionally make up a decision support system. The current state involves the integration of edge computing and cloud computing, to implement highly complex mathematical models.
Al lector interesado se le invita a ver el video A Thousand Brains de Jeff Hawkins.
The interested reader is invited to watch the video A Thousand Brains by Jeff Hawkins. Objective and structure.
Objetivo. El programa del curso está orientado a formar expertos, a nivel posgrado, en modelamiento matemático aplicado, capitalizando 50 años de experiencia del instructor en el área. El curso es ideal para los profesionales que quieran convertirse en profesionales aplicados del modelamiento matemático de alta complejidad. También es útil para los estudiantes de nivel posgrado que estén realizando proyectos de tesis o de investigación relacionados con la analítica avanzada, un paso más allá de la analítica estándar.
Objective and structure. It covers the following topics: state-of-the-art advanced analytics and computing, large-scale optimization methodologies, mathematical modeling oriented to the implementation of artificial hypothalamus, study of applications of high-complexity mathematical modeling applied to real cases, and learn by doing, mathematical models in which the theoretical concepts studied are applied, using current optimization technologies. It covers the following topics: state-of-the-art advanced analytics and computing, large-scale optimization methodologies, mathematical modeling oriented to the implementation of artificial hypothalamus, study of applications of high-complexity mathematical modeling applied to real cases, and learn by doing, mathematical models in which the theoretical concepts studied are applied, using current optimization technologies. Duration. The total duration of the course is 104 hours of training, divided into at least 52 virtual sessions of 2 hours each session. The course is designed for the student to take one class, one session, each week. However, the speed at which the course is taken depends on the student. Project. If the student wishes to carry out an optimization project during the course, they can indicate this to the scientific director. If accepted, the advice for the execution of the project will have a cost equivalent to 25% of the cost of the course. The course is guided by the book Artificial Hypothalamus and Mathematical Programming 4.0 for Industry 4.0 Cyber Physical Systems. The book presents a holistic view of applied mathematical programming, starting with the theoretical foundations of classical optimization and ending with the implementation of highly complex software solutions according to current technological principles. According to the state of the art, the following are studied: artificial brains, parallel and distributed analytics, mathematical modeling, parallel computing, the basic algorithms, and large-scale optimization theories. Given the current technological evolution, the course integrates, at the theoretical level, artificial intelligence and mathematical programming. On a practical level, the design, implementation, and implementation of optimization solutions applied to real problems of companies. Theme plan. The course book has 5 parts. Part 1, Mathematical Programming and Cyber-Physical Systems, Part 2, Large-Scale Optimization Methodologies, Part 3, Integrating Mathematical Programming and Artificial Intelligence, Parts 4 and 5, Real-Life Applications. Part 1, Mathematical Programming and Cyber-Physical Systems. Presentation of the mathematical foundations for the solution of optimization problems. It includes the economic interpretation of optimization models, and the MPEC, mathematical programming with equilibrium constraints, problems. It also briefly introduces the different formats of optimization problems, and the algorithms to solve them. Theme plan. Artificial brains. The future, mathematical programming 4.0. Parallel and distributed analytics. Fundamentals of optimization. Economics, fundamentals, and optimization technologies. Part 2, Large-Scale Optimization Methodologies. Teaching of the theoretical foundations of large-scale optimization, with emphasis on atomizing problems to solve them in parallel computers, and/or in computer networks. The objective is to present the integrated vision of real-time distributed optimization, as the mathematical way to model the cyber-physical systems of Industry 4.0. It is characterized by the integration of multiple algorithms, which continuously cooperate to solve the problems of a multi-agent system, independently using the parallel computers of the agents, and sharing information to cooperatively achieve an optimal solution. This approach is constructed using the fundamental theories of partition and problem decomposition, Benders, Lagrange, Danzig-Wolff, cross-decomposition, and others. Theme plan. Mathematical organization of an artificial hypothalamus. Parallel optimization as an artificial neural network. Expert optimization systems. J.F. Benders, theory, variations, and improvements. Stochastic programming and risk management, fundamentals. J.F. Benders, dynamic and stochastic theory. GDDP and GSDDP, theory, implementation and applications in the electricity sector. Lagrangian relaxation and Danzig-Wolff decomposition. Cross-decomposition. Stochastic and dynamic theory. Other methodologies. Generalized disjunctive programming. Bi-level optimization. Subrogated programming. Primal dual subrogate algorithm. Mathematical programming with equilibrium constraints, MPEC asynchronous parallel optimization. MBD, multi-Benders decomposition. Autonomous, real-time distributed optimization. Part 3, Integration of mathematical programming and artificial intelligence. Presentation of a new vision of mathematical programming, Mathematical Programming 4.0. Structured mathematical modeling, standardization of the formulation of mathematical models to make the algebraic formulation independent of optimization technologies, This makes it easy to migrate mathematical models between multiple optimization technologies. Robotization, making use of artificial intelligence concepts to capitalize on the lessons learned in expert systems to facilitate the construction of the mega models of the future. Theme plan. Relational databases and mathematical programming. Structured mathematical modeling. Tutorial, an example of structured mathematical modeling. Expert optimization systems. Cognitive robots, intelligent algorithms that build advanced analytical algorithms. Optex Expert Optimization System, a cognitive robot for mathematical programming. Advanced predictive analytics using mathematical programming.
Parte 4. Optimización de sistemas industriales. Contienen casos basados en experiencias en proyectos de ingeniería reales. Cada capítulo incluye la formulación algebraica y el diseño de la implementación computacional de los modelos. Varios capítulos incluyen programas en múltiples tecnologías de optimización: GAMS, C, AMPL, IBM OPL, Mosel, Python Pyomo y otros. Plan de temas. Enterprise Wide Optimization. Modelos tradicionales y de última generación. Modelado de cadenas de suministro industriales. Implementación de un modelo de planificación de ventas y operaciones. Tutorial: Sandope para una cadena de cervecera. Planificación integrada de operaciones financieras e industriales. Optimización avanzada en cadenas de suministro bioindustriales. Diseño de redes logísticas resilientes. Caso: distribución en la industria de bebidas. Programación de sistemas industriales mediante modelado de tiempo continuo. Inventario dinámico multinivel utilizando optimización estocástica. Mezcla en procesos industriales. Caso: producción, distribución y comercialización de petróleo. Modelado de procesos químicos. Caso: optimización avanzada en plantas de cemento. Optimización en tiempo real de oleoductos utilizando aproximaciones non-convexuals. Optimización del mantenimiento de activos industriales. Planificación regional integrada. Problema de enrutamiento del vehículos. Tutorial sobre variaciones. Gestión de ingresos de transporte mediante aprendizaje automático y optimización. Optimización de horarios continuos. Caso: operaciones logísticas portuarias. Optimización de horarios discretos. Caso: programación de universidades y colegios. Analítica de recursos humanos. Modelamiento de mercados energéticos. Optimización de redes inteligentes distribuidas en tiempo real. Análisis predictivo avanzado y modelos de demanda de ecuaciones simultáneas. Modelado de la participación en el mercado y análisis predictivo avanzado 2. Fundamentos de Revenue Management. Parte 5. Implementación de software. Enseñanza aplicada de programación de modelos matemáticos de alta complejidad. Para ello se utiliza una tecnología de optimización, por ejemplo, GAMS, AML, u otra y Optex Optimization Expert System. Plan de temas. Fundamentos de las tecnologías de optimización. Modelos matemáticos y modelos de datos. Modelado matemático estructurado. Caso: modelo de electricidad y gas. Optex Madler, lenguaje algebraico de base de datos. Optex Word Excel. Optex Madler 2, servicios avanzados. Análisis de factibilidad. Optimización paramétrica y optimización estocástica. Optex ALMS, modelos determinísticos. Optex ALMS, servicios avanzados. Mateheuristics. Programación disyuntiva y optimización binivel. Optex, programación estocástica. ALMS, tecnologías de optimización a gran escala. Optex ALMS, tecnologías de optimización a gran escala. Optex ALMS, optimización paralela asincrónica. Optex, hipocampo artificial y Optex, hipotálamo artificial.
The course director is the founder and scientific director of RCADT. Engineer Velázquez Bermudez's experience in applied mathematical programming dates back to 1972, which means that he has accumulated 50 years solving real-world problems doing engineering consulting using mathematical models. Engineer Velasquez Bermudez is the author of the book Artificial Hypothalamus and Mathematical Programming 4.0 for Industry 4.0 Cyber Physical Systems. The table presents the summary of the course topic plan, which is divided into 3 main topic groups: Theoretical Foundations, Application, and Technologies. In turn, the groups are divided into 5 parts, which are presented below. A total of 56 sessions are planned. R-CADT is the most applied academic center in the integration of the teaching of mathematical programming and artificial intelligence. For more information, you can consult the URL. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.